Hello, 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 hello. Hi, everyone. Let's get started with the worksheet for today. So for today, our worksheet involves just 3.4. Keep this in mind. What's going to be our 3.3 practice is going to be the homework. And I just double checked in there. It's the thing, I guess I fibbed a little. It's not lengthy, it's just computationally lengthy. So keep that in mind, okay? Again, similar warning, just letting you know. Okay, so one is almost like a review question. It's just evaluating the limits. So let's go. Limit as x goes to infinity of x. Well, that's just going to be infinity. Limit as x goes to infinity of x to the power of n, where n is positive. That's also going to go to infinity. Here we have the limit as x goes to infinity as x to the power of n for n being negative. So recall that we can use a quick substitution idea. I mean, a quick exponent rule idea, which we can rewrite it as, here, let me do that in a different color technically. 1 over x to the power of negative n. And by inequality, we know negative n is a positive number. So that means that if this is bottom heavy, then this solution is equal to 0. Okay. Then for sine, we know that it wiggles the whole time as it goes to infinity, so that doesn't exist. Same thing for cosine as well. The exponential, we know that goes to infinity, and ln that goes to infinity. Here, we can just do a quick trick of rewriting it as x to the power of 1 over 2 as x goes to infinity, and because it's a positive power, we can just say that is infinity. All right, pretty straightforward. Now we're going to go ahead and evaluate the limits with all of these having the gimmick of Hoppitel's rule. Okay, so let's start with number one. Number one says limit as x goes to 0 for this function. Plugging that in, we see the top is 0. And the bottom will be 1 minus 1 minus 0. Okay, so the bottom is still going to be 0. Okay, well, we know that we can just perform a derivative to find this limit. So performing a derivative, we got 2x, and we got um, e to the x negative 1. Or, okay, actually, that's going to be plus 0 and then negative 1. But you can still follow here. And we can also still see that this is going to be 0 over 1 minus 1, which is still 0 over 0. So we need to take another derivative. Limit as x goes to 0 of 2 over e to the x. Well, we know that for here, we can just do substitution to get 2 over e to the 0, which is just 2 over 1, which is just 2. So the limit here is 2. All right. Let's just go down the line here. Limit of 1 as x goes to 1, excuse me. That's going to be 2 times 0 over 1 minus 1. Well, that's 0 over 0. Okay. All right. And then we can go ahead and do the derivative of the top, which is just 2 over x, and the derivative of the bottom, which is just 1. So that gets rewritten to 2 over x, which we know that if we just plug in the 1, we'll get 2 over 1, which is just 2 again. So this one limit is 2. All right, so I'm just double checking my work on my key that I have written here. Okay, right. Let's go. Okay. Over here for 3, let's see, 3 squared minus 3 minus 6, that's going to be 0. 3 minus 3, that's also going to be 0. So 0 over 0. Do a derivative. We get 2x and then minus 1 over 1. That gets simplified to 2x minus 1, which we know we can just do substitution, and that just be 5. Okay. Now, again, you could technically have done this the other way with evaluating, but this is a lot easier. Just keep that in mind. Okay. All right. let's see here. Um, we got 2 plus 14 square root minus 4 over 2 minus 2, which that's going to be 16 square root is 4, so that's 0, and this is 0. Okay, let's do a derivative. This one's going to be really ugly though, but we could still do it. Let me as x goes to 2. Of the top derivative, which is 1 over 2, to x plus 14, so the negative 1 over 2, and then times the derivative inside that, which is 1. And then that's going to be plus 0, so I'm going to write it, and the bottom is 1. Okay, so this just needs to get fixed up to be 1 over 2, 1 over x plus 14. Okay, and then from here, what we do, oh, I'm sorry, 1 over 14, 1 over x plus 14 squared. Okay, and what we do here is we can just use substitution at this point. We'll get 1 over 2, but we'll get 1 over square root of 2 plus 14, which is just 16, square root that's 4. So 1 over 2 times 1 over 8, 1 over 4, skipping ahead, my bad, which is just 1 over 8. All right, pretty good so far. Let's move on to this right side. Okay, so here we have x goes to infinity for the top and the bottom. Well, that's just going to be a glorified infinity over infinity issue. So L'Hopital's rule still is valid here. The limit as x goes to infinity of this derivative, which is 4x, and this derivative, which is 2e to the 2x. Well, again, you can evaluate this, and we see that both of these will go to an infinity. So let's take the derivative one more time. 4 over 4e to the 2x, because the 2 times the 2 will make it 4. And then here, we'll see that we'll have, or actually, you can do this, I guess. You could simplify it to be 1 over e to the 2x. But either way, if you had seen it as 4 over 4 to the e2x, you would have taken the limit to be 1 over infinity or 4 over infinity, which still just makes the limit equal 0, since it's now bottom heavy. That's the answer, but that's the reason why, just in case. Okay. If you write, just a reminder, if you write this on the test, that gets full credit. If you don't write this on the test, but you include this logic, that gets full credit. If one of those is missing, like if you just wrote this is equal to 0, I can't really see that. Or maybe if you put like a little verbiage of like, the bottom will go at infinity faster than the top. Something like that, that counts. But just keep that in mind, guys, okay? We don't want to lose. Maybe we wouldn't get it wrong. You would get points off, which, at the end of the day, isn't crazy, but if you get so many points off during a test, it does become crazy. So please keep that in mind, okay? All right. Over here, x is 0. We're getting a 0 over 0 situation again. So let's do a derivative. We have 4, and then we have 1 over x plus 1. And the derivative of that is 1, so we don't have to worry about that. This is a messy fraction, so that can get simplified into 4 times x plus 1, which we can just plug in 0, and we should see that that's going to be just the number 4. Okay, all right, next one. Again, we're going to have a 0 over 0 situation. So let's do derivative. So derivative of that. I'm going to go ahead and distribute that already just because that's easier for me personally, instead of using product rule for no reason. So the derivative of that top part is just 2, and the bottom part is 1 over x. And again, you simplify this to be 2x, and you can plug it in to get your limit of 2, or your answer of 2. All right. Here we have infinity, or we have x goes to infinity of these two guys. We know that both of these are technically infinity. So we can go ahead and take the derivative of the top and the bottom. We'll get 1 over x. Oh, sorry. 1 over x over 1. That just simplifies to 1 over x, which makes this just a classic bottom heavy function, which makes the answer 0. Okay, right. That is it for these, okay? So let me know if you guys have any other questions. And again, as soon as you start this video, please keep in mind that the homework is going to be annoying. Usually, I didn't put too many questions, but I put questions that have a lot of steps, so it's going to feel like a lot of questions. So please keep that in mind, okay? I'm not just warning you for shits and giggles, okay? That is not professor appropriate. I'm sorry. Okay. Y'all have a good one. I'll see you all in the next video. Bye bye.